Hi, today's topic is graphs in kinematics. So generally there are three types of graphs which we'll encounter. They are displacement versus time graph, velocity versus time, and acceleration versus time graph. Additionally, we'll also come across displacement versus velocity, displacement versus acceleration, and acceleration versus velocity graphs. In kinematics, mostly we'll be solving these graphs, relating them to the equations of motion. As we know, for uniform accelerated motion, we have these three standard equations. V is equal to u plus ad, v square minus u square is equal to 2as, s is equal to ut plus half ad square. In these three equations, the variables are marked in pink. That is, v and t in the first equation, v and s and t in the third equation. So when we will have to plot a velocity versus time graph for a uniformly accelerated motion, we'll be making use of this first equation. Now coming to some other useful relationships which we may make use of in problems are these differential relationships where velocity is ds by dt. When you differentiate displacement with respect to time, you get velocity. Similarly, differentiating velocity with respect to time, acceleration. Double differential of displacement with respect to time gives acceleration. And now relating acceleration, velocity and displacement, we have a is equal to v into dv by ds. Also, these points are worth noting. In a graph, a slope is given by dy by dx. That's differentiating the y-axis component with the x-axis component. And area under the graph with x-axis is usually given by integral y dx. Now, coming to the types of problems we'll encounter in JEE Main relating to graphs, we might be given a graph and we'll be asked to interpret and find values. So, and there another type is, given a situation, you'll be asked to plot a graph and then interpret from that. So we'll be discussing all the types in this video. Now, let's see some standard graphs. These are few standard displacement versus time graphs. When a body is at rest, you can see you get a graph like this when you plot displacement with time. With varying time, the displacement is constant. That's the body is at rest. Uniform motion, that's when a body moves with an uniform velocity. The plot goes like this. With increase in time, there is a linear change in displacement. That is, you can find the slope here to be a constant one, which implies that this velocity is constant. Uniform accelerated motion, acceleration is change in velocity. Uniformly accelerated motion is there is a uniform change in velocity. As you can see, the variation of displacement with time, the velocity is given by the slope. So a slope at each point gives the instantaneous velocity, and you can see a linear increase in the slope, that's a linear increase in the velocity, indicating a uniformly accelerated motion. Similarly, uniformly retarded motion is when the acceleration is a negative value, that's velocity linearly decreases with time. You can observe the trend with the slope here also. So yes, these 2 points for displacement time graph, slope gives the instantaneous velocity and the graph gives the relationship between instantaneous displacement and time. Now coming to the velocity time graph, for uniform motion, that's a constant velocity motion, you have a plot like this, horizontal line parallel to the x-axis. For a uniformly accelerated motion, you can observe a graph like this. Here u is the initial velocity, and with increase in time, you can see a steady increase in the velocity. Here the slope gives the acceleration. So you can find the acceleration here is constant. Similarly, a negative acceleration, that is retardation. When a body moves with a non-uniform acceleration or retardation, you can find a variation in velocity and time like this, where there's no proper trend in the slope, that is, there's no proper variation of acceleration. So this is non-uniform acceleration. Here in velocity time graph, the slope gives the instantaneous acceleration, tan theta gives the instantaneous acceleration, and the area under the graph of velocity and time gives the displacement in the given time. For example, from time 0 to t0, the area under this graph will give the displacement of the body from 0 to t0. Okay. Now coming to the acceleration time graph. For an uniform motion, that's constant velocity motion, the acceleration is 0. So you can find a graph like this. For uniformly accelerated motion, there is a constant acceleration, this value. Similarly, for uniform retardation, there is a constant negative acceleration. And for a non-uniform acceleration, there can be a random variation like this. So in acceleration time graph, the area under the graph gives the change in velocity in the given time. For example, from time t1 till t2, the area under the graph gives the change in velocity from t1 to t2. So that's it about the general graphs. Now coming to some impossible graphs. So you can observe in these two graphs, for a single time you have two displacements, and here for a single time you have two velocities, which is not possible, practically. And here also an infinite slope, that is an infinite velocity, or an infinite slope here, which implies infinite acceleration, is hypothetical, so it's not possible. Some key points to be remembered while solving problems. As you all know, displacement, velocity, acceleration are all vector quantities. They can be positive, negative, or zero. So how do we represent them in graphs? Usually, when it comes to area under the graph, in the first quadrant, the area is considered to be positive, and in the fourth quadrant, it is negative. First quadrant and fourth quadrant. Okay? And slope. As you all know, say for in a displacement time graph, here this is theta, which is an acute angle. Here for an acute angle, tan theta is positive, so it's considered as positive velocity. For an obtuse angle like this, tan theta is negative, which means negative velocity. That's negative and positive velocities imply the direction. So for obtuse angle, we usually consider it as negative. Similarly, for points, say for a velocity time graph, the positive y-axis is positive velocity, negative y-axis represents negative velocity.